Welcome back to General Structures 2 and Lateral Forces, Lesson 3 quiz, question number 7. And this is part 2. And we left off, we had just done the method of joints at point A, or joint A, and we had come up with the FAB and the FAC, and I went ahead and put it up here. So I'm going to erase this stuff down here. And as you can see, so far our assumption of number 2, where it's stated that the top chord is in tension and the bottom chord is in compression, remains true. So next thing we can do is you can pick where to go to. And without doing too much investigation, you can see that, hey, this is a zero force member. That's compression. That means it's going to go in. This is going to be equal to opposite. That means it's going to go in. It's also going to be in compression. So this is FCB is going to be 30K. 30 kips. All right. Now, what else can we see here? The best way to go. And hopefully you're starting to notice that this is in compression. So that's going to go into the joint. That's going to go into the joint. That's going to go into the joint. Hopefully you're starting to see that, hey, these might be zero members too. Zero force members. This one, this one, this one, and this one. But we're not 100% sure yet. I'm pretty confident that that's the way it's going to end up. But we're not 100% sure. So in other words, we didn't need all these members in here. These main members are taking the force. But let's go ahead and figure that out. So we are going to head and go to do the method of joints at point B. And then we have that coming up here like so. We have this coming down, which we know is going to be 31.62 in tension. And we know that the components of that were 10 kips and 30 kips. And now we have a zero force member, so we don't need to do anything about this. Do anything about that. We'll just pretend it's not there. We're going to have FBD as an unknown, and then we're also going to have FBE as an unknown. And what you could do is, I'm going to redefine my, to make this easier, I'm going to redefine my XY axis as Y and X. So these right here are only X direction. And once you do that, you start to look at this and say, hey, okay, well, let's look at my Y components. Well, this doesn't have a Y component. This FBD doesn't have a Y component. But this FBE does. And if you look at it, heck, that's the only Y component there is, so that has to be 0. And therefore, FBEX is also 0, and therefore FBE is 0. Oh, wow, so that is a zero force member. And this is still 31.62 kips in tension. All right, that was easy. Wow, do you see any other issues coming about here? Well, if we do that, we have the same issue over here where this is going to be a zero force member. And if we do that, then this is going to be 30 kips in compression. And if we do that, we have the same issue at D that we had at B, where we change the XY axis, which obviously you don't need to do that, but I think it's more intuitive when you do that. You can see that, hey, that's why it's a zero force member. So this is also a zero force member, and this is going to be 31.62 kips in tension. All right, now we've come to the end. And you can see pretty darn easily the way this works out. And I don't even have to cut it or do anything. We've got the same type of, we've got 30 going this way, so we're going to have 10 in this line. 10 in this. This is going to be 10. 10 kips, and it's kind of hard to write sideways on this computer screen. So we have 10, and is that compression or tension? Well, let's think about it. This is going up, so that's going to have to go down, and therefore it's going to be in compression. Let's check that with the top here. That is tension, so it's going down, and therefore we need it to go up into the joint, and therefore it's compression. Yeah, that works out, and that makes sense. Alright, so we've got all of our members here. We have a lot of zero force members in the middle. And let's revisit the 1, 2, 3, 4, and 5 and see which is correct and which is not. So, number 1, all of the diagonals are in tension. And we weren't 100% sure about it, but if you look at it and all the diagonals. Now, I'm not assuming this is a diagonal. The top chord is not a diagonal in my mind. This is diagonal and this is diagonal. And therefore it says they're in tension. No, they're not in tension. They are zero force members. And even if you did assume these were diagonals, those are in tension, but these still aren't. But no, don't assume those are diagonals. That's the top chord. Alright, we've already said 2 is correct. We know it is. Top chord is in tension. The entire top chord is in tension. The entire bottom chord is in compression. 2 still holds true. Go on to number 3. All of the verticals are in compression. Our verticals are not all in compression. We have 2 zero force member, and you could call this a vertical. I don't know if you want to, but either way, that's incorrect. Number 4. All diagonals have zero stress. Well, I would consider this a diagonal and this diagonal, and they have zero stress. So yes, 4 is okay. Remember, this diagonal member is the top chord. It's not a diagonal per se. And then number 5, all of the verticals have zero stress. And that's tough. It depends on whether you call this a vertical or not. And let's go ahead and see what they did in the back. Actually, is there an answer that's just 2, 4, or is there a 2, 4, and 5? There isn't a 2 and a 4. So I'm guessing that 2, 4, and 5 is the best answer. They do not consider this vertical, even though it's going vertical. It's more of like you could call it an end diaphragm. I maybe don't like that answer 100%, but the other verticals are definitely zero force members that are clearly a vertical, and it looks like 5 is also correct because there is not an answer for just 2 and 4. So the answer is D, 2, 4, and 5. Once again, answer is D for question number 7.